that make sense? Questions about these things? Going. This is like a quick review. How about this, negative exponents? That is also a problem. Let's see, negative exponents. X to the minus 5 times x to the 17. X to what is that? People in the back, how are you guys doing? Can you hear me well enough?
X to the power of 12.
Let me check. Yes, it is 12. Thank you. How did you know? It's minus 5 plus 17, which is x to the 12. Thank you. Good. And one more. 1 over, so let's go backwards. 1 over third root raised to the 7.1. X to what power is that? My x becomes so big. Who knows? That is 7.1 over here. 7.1. Anyone want to yell from the back? X? Negative 7.1 over 3. Perfect. Do you all agree? So negative came out from the fraction. It was in the denominator, so I can fix that by making a negative exponent. Then 7.1 was at the top, so it goes to the top. 3 was a root, so it goes to the bottom. Remember these things. I will refer to this in the future as a lecture 0. More. Square roots and stuff like that. The most popular mistake is, so I will do not perform this. If you have a square root, x plus or minus y, you should not write it down as square root of x plus or minus square root of y. This is a very common mistake, so I want to point it out. Don't do that. Don't do that. You cannot break roots like this. You cannot break squares like this. There are formulas for these things. You can break them only when they are multiplied. So, yes, you can do that if you have, but note, you can do that if you have x times y. Then it's the square root of x times square root of y. So that's the thing. Products and quotients are easier to work with versus sums and differences. One more thing is with parentheses. So, we were making a video for this class with a colleague, and he was making this lecture for the video for you guys, and then he did like this. He was English speaker, so he was saying, minus x squared is not the same as minus x squared. So he made a pause like this. And that was kind of funny. I found it funny. So that is not the same. Do you all agree? Parentheses will kill your grades in math classes. You have to put them. You have to have parentheses or else you're screwed. I teach calculus 1, 2, 3 in upper division classes, and people still lose parentheses, and then one negative sign, breaks the whole thing. So the left-hand side is minus x squared, but the right-hand side is positive x squared. So minus 2 squared is not as minus 2 squared. Minus 4 versus 4. Remember that. That will be important. Which formulas do you need to know, at least at the beginning of this class? That is important. In general, I do recommend you to make a formula sheet. You're not allowed to use it in the tests, but it's nice to have it because you visually will remember where that formula used to be located, and then it will help you on the exam. Who remembers this formula? X plus or minus y squared, square of sum or difference? Yeah. Someone else? Maybe someone new? Yes.
X squared
Yes.
plus minus 2xy
Yes.
plus y.
Thank you. Very good. Square of sum or difference. You square the first term, add or subtract double product. Oh, I should not do that. And then square the second term. So that is a top 1 formula. We'll be using it literally every day. So you're supposed to know it very, very well. And it's supposed to call you at night, wake you up and ask you this formula. You're supposed to know it. It's important. Difference of squares. Who knows that one? Anyone? No, you're being too much already. I need to wake up other people. Wake up, people. Who knows? You guys know it. And it's okay to be wrong or guess. Just like guess. Yes, what do you think? Yes, you can tell me.
X plus y and x minus y multiplied by x minus y.
Do everyone agree, disagree? Any comments? Agree? Okay, well, if you did not know, now you know.
Yeah, but
Yeah?
sorry.
Yeah. If you did not know, now you know. This one is also very important. So formula number 1 and formula number 2. I will be referring to those formulas a lot. And I will be like, how come you forgot formula number 2? And we might be going both directions, here and there. So, then there's a note, important note. Do not, again, do not. You will do mistakes like these, so I want to kind of try to prevent these mistakes. If you have x plus or minus y squared, you will be unfortunately stressed during the exam, and you will try to break it as x squared plus and minus y squared. As you can see, there is this extra double product term supposed to be there, and you lost it. So just like with a square root, and the top, cannot do like this with the square roots, cannot do like this with the squares or cubes or anything. That's why we have those special formulas. More. Quadratic formula, your favorite one. You're at least supposed to remember this one. I know summer was long and you were studying at home. Let's do it. Ax squared plus bx plus c, which is equal to 0. This is a quadratic equation and it has a solution. Either two solutions or one solution or no solutions. That is basically where parabola is crossing the x-axis. Maybe it's crossing twice, then there are two solutions. Maybe it's crossing only once by touching it with a vertex. Or maybe it's floating in the air, then there is no solution. So 3 cases. Of course there are solutions in the imaginary numbers, but we don't really go there in this class. So, very funny thing. What I learned from living in the United States, that Americans like songs. You guys like creating songs about all kind of stuff in physics and math and chemistry. So there is a song for the quadratic formula, apparently. Russian style is very, straightforward. You have to learn it, go learn it. We don't have a song for the alphabet, for example. Like, we just learn it. And we have 33 letters. So we have more to learn. And then the quadratic formula, same thing. I did not know how many there are songs about quadratic formula, and they all were done by Americans. It's very interesting. So who wants to perform? The quadratic formula is minus b. What else? Plus or minus square root b squared minus 4ac all over 2a. So you can sing it during the exam, but quiet. I am fine with that. Just don't distract others. Remember that. Now, remember that you're not supposed to forget extra solutions. For example, if it's a simple case when x squared equals 9, you don't have to use this formula because you know what gave you 9 when you're squaring it. That was 3. Is there a mistake here?
Yeah.
Which one?
It should be negative and positive.
Exactly. There are 2 roots here, plus and minus 3. Thank you. Don't forget that. So don't lose the second answer when you have a square. Questions before I move on? I'm going fast with this because we assume that you know it. And if you don't, that's nice that we're reviewing it right now, so that's also good. But I will be referring to this lecture later, like, hey, we did it in lecture 0. Please go and check it out. Factoring. Factoring. Factoring is when you have to collect some terms that look alike and then factor them out. 3x to the 5 plus 6x to the 7 minus 9x to the 11 equals, oh, that is weird, x to the 7. X to the 7. Factoring means you want to divide by the same thing that repeated everywhere. So factoring means dividing. If we ask you to factor something, you want to find, first of all, a variable with the smallest exponent. So what is the smallest one from 5, 7, and 11? 5. So I'll be factoring x to the 5. And then if it's possible, maybe you'll find a constant to factor. Not always, but in this case, seems like we can factor 3, right? So when I'm factoring, I'm open the parentheses, and now I'm dividing each piece by 3x to the 5. 3x to the 5 over 3x to the 5 is 1. 6x to the 7 by 3x to the 5. Either you use a pencil and write it down, or you just talk by yourself. 6 over 3 is 2. X to the 7 over x to the 5 is the formula I just showed you. You subtract the exponents. So it will be x squared. Did you catch up? 7 minus 5. That's why those formulas are important. 9x to the 11 over 3x to the 5 will be, well, minus 9. Minus 3, because minus 9 over 3 is 3. X to the 11 over x to the 5, 11 minus 5 is 6. And it's not x. It's here. X to the 6. And for example, you're solving this. Solving for zeros. For example, you set it equal to 0. What do you do now? So original equation would be hard to solve for 0. The factored one is easier. You take each factor and set it equal to 0, because each of them could give everything 0 or all of them. Thus, you will write down 3x to the 5 is 0. That gives you solution right away. And 1 plus 2x squared minus 3x to the 6, 0, also gives you solutions. And that is a system. So you will see that we're going to be doing that quite a lot. Solving solutions actually has lots of applications, and I will be showing you lots of fun applications in biology, since most of you like that. That's also one of my favorite topics in mathematics, is application of mathematics in biology, because I was doing PhD in mathematical biology, in modeling epidemic spreads in hospitals, American hospitals, and I do know a lot about mutation of the bacteria, antibiotics, and lots of stuff. And even genetic mutation. At some point I was doing genetic mutation for fun. And a little bit microbiology, yes. A little bit of microbiology. So I will show you lots of examples about that, because it's pretty cool actually. Fractions. Fractions. Somehow students do not like fractions. It's like a big deal, surprisingly. It's a big deal with fractions. So you should always stop me in class and ask questions about these things. Don't be afraid to sound behind or whatever. To be honest, we, all of us, all in the same boat. We're doing this class, and if you ask this quick question, why 2 squared was 4, it's easier for me to answer it than you getting stuck and then you feel frustrated. So don't be afraid to ask. It's always fine. For example, x plus y over 15. These can be broken into 2 fractions, x plus over 15 plus y over 15. To review that. Why I'm reviewing this? Because I need to show you that it doesn't work the other way around. If there's a 15 at the top and then x plus y at the bottom, then you cannot break it into 2 fractions. So sum or difference in the numerator makes more fractions. But sum and difference in the denominator does not, because dividing by things is more complicated than multiplying. Moreover, if you have also, do not, let's do do not, one more do not. This is one of the most popular mistakes, to do not. What if you have x, let me do in red. This is very popular mistake, unfortunately. X plus y over x. And students usually like, oh, of course it cancels out, so the answer is y. That is not how you do it. You cannot cancel out things without factoring it out. So you should not do it this way. You're supposed to break it into 2 fractions. You're supposed to write down x over x plus y over x. Then you can cancel out the first one. X over x is not 0, it's actually 1. So the answer will be 1 plus y over x. So that is important. If you see common things in fractions, don't be in a rush to cancel them out. That usually leads to lots of mistakes. Fractions 1 and 2. How about fraction over the fraction? X over And let's do 3 over 17, like so. Are you feeling comfortable working with fraction over fraction with fraction inside? And because we're going to have this logarithm inside of the fraction, inside of the sign, stuff like that. So this is how so good job. This is how you should see it. You should see it like this. X is being divided by a fraction. When you divide by a fraction, you flip it, and then you're allowed to multiply by that result. Officially, we call it multiply by the reciprocal. Reciprocal means flipping. So I'm multiplying by 17 over 3. So the answer will be 17x over 3, or 17 over 3x, whatever. So flip. Yeah, you can do, no, not 3x. Actually, that's a good question.
Sorry, no, it's because you said that first. I was pretty sure that.
That's actually a very common question. Such a good job that you did that. It is 17x over 3, but you cannot put it as 17 over 3x, because when you multiply by x, it can't go to the denominator. Remember that. It will happen soon, so you will see that's why it's important. Now, so that's how you should see it carefully. At some point, I was supposed to maybe show you this extra step. It was 1 over 3 over 17. 1 over a fraction is multiplied, it means multiply by the flipped fraction, or reciprocal. Reciprocal. Now, let's see. More notations. Students also get confused by this notation. This depends on the school you came from. So minus 2/3 can be written as minus 2 over 3, can be written as 2 over minus 3, okay? Usually two first notations are mostly common ones, not the other one. So that's also, keep in mind that. And that is also good. Finally, what you can and cannot do. Let's do that. 5. So it's going to be 1 over x times y. Can you break it into two fractions? What do you think? Let's vote. Yes or no? What do you think? So products, yes. Sums and differences, no. And sums you can if it's numerator. Again, let's be careful with this. That's why it's confusing. Denominator, you always have to think carefully if you can break it, but if it's a product, you can. That is actually 1 over x times 1 over y. Numerators are being multiplied 1 times 1. Denominators being multiplied x times y. Now, let's do what we can do. Or let's check if you remember. Can you do it or not? So let me check you if you understand. X plus y over 7 plus y. I want to cancel out. It's going to be x over 7. Can I do that? So, oops. No. Cannot cancel out things which are added. Next one, let's check this one. X times y over 7 times x. I want to cancel out and write down as y over 7. How about that? Yeah. We can do that if x is not 0. Remember, we cannot cancel out zeros, but if x is not 0, yeah, why not? So the answer is yes. They all agree? You see the difference, products and additions and stuff? And how about this one? This is the weird one. 15 over 15x plus 15y. Can I cancel out anything here? Yeah. What do you want to cancel out? 15. Before canceling out, I need to see it being multiplied, because we just agreed that you cannot cancel out things that have sums or difference in the denominator. So technically speaking, you can skip this step, but it is there. 15 is being factored out, and we just learned how to factor things out. Then it's going to be x plus y. Now it is multiplied. Since it's multiplied, I can cancel out, and the answer is 1 over x plus y. That is also good. What do you think about that? So the first lecture is introduction, nice lecture, something simple and pleasant. Well, I will not call it simple. Let me put yes here. In case you don't know this, you should not feel behind. That was long summer. Many of us don't remember what is going on. But now you have something to review. And when you start your homework, you will see those things there. You will see limits when you have to factor something. You will see division and fractions. And now, hopefully, you feel a little bit more comfortable. On Monday, please don't be late. I will start right away. No syllabus, no happy talking. We're going to do limits, minute 1 of class. Have a good weekend and see you on Friday. If you could not do the iClicker, sign here. What?
There will be a map of assignment.
Yeah.
I'm cool with that. That's great. I just want to be sure I do it.
What is the name?
Great. Sorry about it.
Nice to meet you, Spencer.
Nice to meet you. Spencer. Yeah. You had troubles with the app?
I have a class that's like all the way over in another building.
Oh,
It's
you're
like
running?
a 20 minutes walk, and I have 15 minutes to get from one to another.
I'm fine people being late, just quietly come and sit.
Yeah.
But it's bad. I kind of always start on time, so you're the first one, yeah. So, yeah, good luck with them.
Thank
It's
you.
like exercise every time.
Yeah, I'll try to come like
If
earlier.
that, maybe try to leave earlier. What your classes? Is it important?
English.
English
I only
class.
write my name, or do I write my
Yeah, just your name. Thank you.
Thank you.
I like your pants.
Thank you.
That's pretty cool, especially the pockets. Oh my
Yeah, I really
gosh,
like
I
that.
love
It's
it.
my ID and,
But with the belt, it looks classy.
thank you.
It's really nice.
Thank you so much.
Is this if you couldn't use the
Did you try to use iClicker?
Yeah.
Did you work?
No.
Yeah, then put it.
I tried using it in my bio class before this too, and it still
Oh,
didn't work.
see, we're all trying to use it, but it's not necessarily
I
working.
know.
Hi.
There is homework due this weekend, you said?
No. We always do. Well, no.
Are you referring that this will be practice on the homework?
Yeah, it's just review.
Just
This is the
review?
review.
Okay.
The first homework will be due next weekend.
Okay.
Usually Monday, I think.
Okay, and I wanted to introduce myself. I'm Chad.
Chad, nice to meet you. Welcome. Hi.
We just wanted to introduce yourself. My name's Kate,
Lila.
and we're on the beach volleyball team here
Nice.
at ASU. So,
You'll be traveling, yeah?
yeah, we'll be traveling, but we'll send you our schedule once we get it.
Yep.
It should only be twice.
I think it's
this
twice because
semester.
we're spring school.
No problem.
But
Yeah,
we
that's
might
good.
have two. But we just wanted to communicate because our
Yeah.
practice also ends at 12, and so we come right here after practice.
Oh, you run just like that girl. She said the
Yeah.
same thing.
So,
Yeah.
but we should be
So
good.
we should be fine. We just want
Yeah.
to communicate.
I'm
it.
fine people with being late a little bit, but you will miss stuff. So just quietly come and sit.
Yeah, we should.
But,
But we just wanted to
yeah.
communicate. Thank you.
I like your necklace.
you.
So sweet.
You said you upload these notes.
Yeah, I'll put it. And I think I finished recording successfully. Hopefully I even recorded everything.